Hey there, Earth Science fans. Before I start the lesson, you have to watch this YouTube video called The Helical Model, Our Solar System is a Vortex. Basically, it questions the model of the solar system that you guys probably learned about in school, and it's a great way to start off our conversation about the solar system. Anyway, you have to check it out. I'm going to put a link in the description on this video. Again, it talks about the vortex model of the solar system, and this is totally different than the heliocentric model or the traditional model of the solar system that we all learned about in school. So please check it out before you watch the rest of this video. Alright guys, so today we're learning about the solar system, and here's one of my favorite images. Now obviously this is a computer representation of the solar system, but I just like how it has all the planets lined up in order like that. And before we get started, just ask yourself, what do you notice about the planets in our solar system? Take a look at them all there, and do you notice anything interesting? I mean, there's lots of things you could say. Now, I'm also going to draw a line right here and see if you notice anything when I do that. Now, guess what I'm trying to get at, and you may have come to this understanding already, is look at the size difference of these planets over here on the left versus these planets here on the right. Like Mercury, Venus, Earth, and Mars are tiny compared to Jupiter, Saturn, Uranus, and Neptune. I mean, that's crazy. Like those planets on the right are huge, and the smaller planets on the left are, well, they're small. So why is this? So one thing we're going to go into today is that the solar system is divided into two types of planets. The smaller ones on the left, like Mercury, Venus, Earth, and Mars, are called terrestrial planets because they're made of land. They're rocky. You can land on those planets. They're made of solid material, like Earth, like Earth's crust. We can walk around on Earth, obviously. We could walk around on Mars, too, but nobody's ever been there before. The Jovian planets are huge, and they're made of gas. You couldn't land on the surface of Jupiter. You would sink through because it's made of gas. Same with Saturn, Uranus, and Neptune. And the division between these two types of planets is going to be one of the major focuses for our lesson today. Alright, so let's take another look at this view of the solar system, and I'll put the line back here, dividing our terrestrial planets on the left from the Jovian planets on the right. And let's notice some more things about them. First of all the terrestrial planets are located closer to the sun. So they're smaller, they're rocky, and they're closer to the sun. And then all of the Jovian planets made of gas, and the larger ones are on the right, are further away from the sun. So why would that be? Why would the rocky planets be close to the sun and the gassy planets be further away? Well, this has to do with when the solar system was forming. Basically, the sun formed a little bit earlier as all the mass collected in the middle. And as enough mass combined in the middle of the solar system, something called nuclear fusion happens, and that's when the star starts creating energy and creating light. That's why the sun is bright, because it creates light. So when that happened, there was a huge wave of energy that shot throughout the solar system. So energy shooting out from the sun and pushed on all the material that was in the solar system. So the heavy material, like rocks, were a bit stronger. So they didn't get pushed as far away as the gas. Gas is much lighter than rocks, so the gas got pushed to the further reaches of the solar system. That's why all the gaseous planets are far from the sun, because they got pushed away. But the rocks, which are stronger, they stayed closer. So that makes sense for the organization. But why are the gas planets so huge? Well, gas is lighter and less dense than rock, so gas expands. So those planets were able to get really huge. Rocks are a bit stronger and more dense, so they don't expand like gas does. So those planets stayed small, while the gaseous planets got really huge. Alright, so now I'm going to go through each planet briefly just to give some quick facts and overview. Starting with Mercury, the closest planet to the sun. It's also the smallest planet in our solar system. Not a ton of stuff going on On Mercury, it's famously the most cratered planet. That means there's a lot of impact craters left over from meteors or asteroids that hit the surface. Mercury doesn't have an atmosphere, and atmospheres can burn up any rocks like meteors that enter near a planet. So it has a lot of impacts for that reason. It also doesn't have any liquid water or anything that would erode or remove those craters. So those craters, once they hit there, they pretty much stay forever on Mercury. This is just a beautiful photo of all the different chemical compositions on Mercury. That's not what it would actually look like. They just colored each region according to the different chemicals that make up the rocks on Mercury's surface. Now, even though Mercury is the closest planet to the Sun, it's the second hottest planet, which is strange. You'd think it would be the hottest because it's closest, but it's the second hottest. All right, the second planet from the Sun is Venus, and in my opinion, a much more interesting planet than Mercury. Venus is very close in size to Earth, and it is the hottest planet in the solar system. So the second closest planet to the Sun is the hottest one. Now, why is that? Well, here's a really cool picture that we recently took. There was a spacecraft that actually landed and survived for a little bit on the surface of Venus, and you can see that the sky is really this kind of gross, yellowish, kind of disgusting looking color. Well, that's because the atmosphere is full of gas and a lot of carbon dioxide. So there was a really intense greenhouse effect on Venus, global warming, basically. So I think from volcanic eruptions, they released all this gas that stayed in and became the atmosphere of Venus. Well, carbon dioxide absorbs heat. Just like it does on our planet, it absorbs heat on Venus. So because of all of that global warming, Venus actually became the hottest planet in our solar system. Here's a cool view of Earth, the third planet from the Sun, as taken from the Moon. So this is a photograph of Earth taken from the surface of the Moon. And our planet is unique in a lot of ways. It's the only place that we've found life so far in the solar system or anywhere else in the universe. We've got a complex atmosphere that's habitable. We can breathe oxygen. Plants can breathe the carbon dioxide there. Those gases are in the proper proportion to support life. There's also liquid water and a ton of liquid water, which scientists have found is pretty important for life as we know it, and probably important for life on other planets too. And so we look for liquid water when we're looking for other places where we could find life. All right, after Earth, we have Mars, which is called the red planet because its soil is rich in iron, which has a red color. A couple of interesting things to talk about with Mars. It's home to the solar system's largest mountain called Olympus Mons, which is actually a volcano. So not only is it over twice the size of Mount Everest, but it's a volcano, which means that Mars had evidence of volcanic activity and possibly plate tectonics at some point. Speaking of the past on Mars, there's erosion. There's evidence of stream erosion on Mars. These are evidence of meandering streams, and what's left over is just the valleys that those streams left. So that means there probably was liquid water on Mars, which means that Mars used to be a much different place. So we know a lot about Mars because we've studied Mars with these rovers. This is a selfie. I'm not sure how it got this picture, but we've sent several of these up there. There's currently 2, I think, still in operation on the surface of Mars. So we're studying Mars a lot for a couple reasons. One, it's pretty close to Earth compared to the other planets, so it's easy to get to. 2, because of its past, because we know there used to be water there, and for another reason, we think that Mars might be a good place for life. So not only would that mean that if we ever had to leave our planet, Mars might be a good choice for a place to go to start a new planet, but also it might be a good place to look for evidence of life. That means maybe microscopic bacteria that might still be alive on Mars' surface, or fossils of old things that used to live on Mars, like things that maybe lived in the streams that we know were on Mars. And that's because Mars is in the habitable zone, sometimes called the Goldilocks zone, because it's just the right temperature for life. Notice from the diagram that the habitable zone is all this green space, and Earth and Mars are both in the habitable zone, whereas Venus and Mercury are too close to the sun and therefore too hot to support life, and these planets, Jupiter, Saturn, Uranus, and Neptune, are too far away or too cold, probably, to support life. We think that Earth and Mars are just the right temperature to support life. So when Mars did have liquid water on its surface, or even today in the form of microscopic bacteria, we think it might be possible to harbor life. Alright, so after Mars we have Jupiter, which is the start of the Jovian planets, or the gas giants that are further away from the sun. Now if we look at the surface of Jupiter, we see all this beautiful swirling in here, and that shows that it's made of gas. It's also because this planet is spinning around really fast. It has the fastest rotation of any planet. It goes through a full rotation in about 10 hours. And it's a huge planet too, so that means the surface is really whipping around at a really high speed. Because of this fast rotation, all the gases rotate really quickly, and that kicks up really big storms. There's the famous huge red dot here. That's like a big hurricane that's been going for millions of years. Jupiter's the largest planet in the solar system as well. After Jupiter, we have Saturn, and I just love these images of Saturn, and they look like beautiful paintings almost, but they're actual photographs taken from the Cassini spacecraft, which was orbiting Saturn up until I think 2016. It got all these great photos, just the dramatic shadows, and right here we have the sun in the background, so that's like a Saturn eclipse. Now Saturn is famous for its rings. It's not the only planet with rings, but it has the most prominent and visible rings. And what they think is that that would have been another moon, or that early in the life of Saturn there was a moon of Saturn that formed too close to the surface, and so it wasn't stable, and the gravity of Saturn broke it apart. But now we just have these beautiful rings. All right, our next Jovian is Uranus, and don't know too much about it, but it's got this light blue color, which is kind of cool. It's made of gas, as we know, because it is a Jovian planet, and Uranus is tilted at a 90-degree angle, so it's rotating up and down, I guess, in comparison to the other planets. Most of them are rotating in a horizontal fashion compared to each other. Obviously, it is space, and there is no up and down, but if you compare them, they're all pretty much rotating on the same plane, except for Uranus, which means that it was tilted at some point. Maybe there was a huge impact or something. I'm not quite sure, but it's the only planet like that. One interesting fact is that because of all the methane, which is a carbon-based molecule, a gas, there's a diamond cycle on Uranus, which means that it rains diamonds. We have a water cycle on Earth, but there's a diamond cycle on Uranus, and it's just cool to think about, like all those pressurized carbon molecules turning to diamonds on another planet and raining down from the sky. And the furthest planet from the sun is Neptune, the last Jovian and the smallest gas planet. It's got this beautiful blue color. As you can probably figure out, I don't know a ton about Neptune. It does have the same diamond cycle that we talked about on Uranus. And it became the furthest planet when we demoted Pluto. So now Neptune's the furthest planet from the sun. Alright guys, I know I've said this every time, but please make sure you're keeping up with your thinking rights. And this thinking right is more interesting than most. It talks about this difference between the vortex model of our solar system and how that's different than the traditional heliocentric model that we learned about in school. So again, check out that YouTube video that I promoted at the beginning of this one to learn more about this vortex model. Alright, so let's take it back to that original image of our solar system. We've got our terrestrial planets here, these tiny guys on the left, and then the Jovians on the right, the large gas giants. So going through all the characteristics, we know that the Jovian planets are Jupiter, Saturn, Uranus, and Neptune. And it's kind of a little hint. I always remember that the Jovian planets, which starts with a J, begin with Jupiter. And Jupiter is the first Jovian planet, and they both start with a J. So I just always connect that word Jovian with Jupiter for that reason. They're larger. We talked about that. They're made of gas, so they expanded. So their diameter is larger. Their mass is high. That means they're heavier. Their density is lower because gas has a lower density than rocks. Their distance from the sun is far. Their period of revolution, that means how long it takes to go around the sun, is long. Because they're further away, it makes sense that it would take a longer time to go around the sun. That means they have longer years, because a year is defined by how long it takes a planet to go around the sun. They have a short period of rotation. That means they spin really fast. Because gas is light, it whips around really quickly. Think about the clouds on Jupiter spinning around really fast. So these gas planets spin quickly. Our terrestrial planets are made of rocks. We got Mercury, Venus, Earth, and Mars. They're solid. That means you could land on these planets. They're smaller. That's the first thing we said. That's very obvious when we look at the image. They're tiny in comparison. And that means they also have a low mass because there's less material there. Even though rocks are heavy, there's way less substance in the terrestrial planets, so they have lower mass and they're lighter than the huge gas giants. Their density is higher because rocks have a higher density than gas. They're nearer to the sun, and that gives them a short period of revolution. That means that they take a shorter amount of time to go around the sun. And that makes sense because they're closer to the sun. The period of rotation is on average longer than the Jovian planets. The material of rock is more strong and it doesn't spin as quickly as gas. All right, finally, this data table from the reference table has all the information that you need to know about the planets. I have them divided up with the terrestrial planets here in red and the Jovian planets in blue. Remember, Jovian and Jupiter both start with J, so I know that the Jovian planets start here. And you can discern a lot of the trends that we talked about, like the distance from the sun and how that increases as we go through towards the Jovian planets, the period of revolution also, the period of rotation, or how long it takes to spin around once, the eccentricity of the orbit, or how stretched out or oddly shaped the orbit is, the shape of the orbit, the diameter, which is the size of the planet, the mass, which is how heavy, and the density, which is how compact the materials are on that planet. All right, that's it for me, and I'll see y'all next time.